All right, we're going to continue on with our factor of trinomials. This is called the AC method. All right, and again, we're working with these ax squared plus bx plus c types. Okay. I've only got 7 homework problems on here because these are a little longer, a little more steps. So they do. I don't want to, beat these in, like, I don't want to beat a dead horse, as they say. So we'll just do a few of them. All right, so this time we have a lead coefficient of 2, and I can't take it out as a GCF because these don't have 2's in them. So I'm stuck, so I have to use this method. Okay, so your steps over here, I'm just going to write them over here. Okay, so you want to multiply A times C. So your steps here would be to multiply 2 times 5. Your A is the term in front of your x squared, or c squared in this case, and your C is the constant. Okay. Now, we want to make factors of this number, just like before. Okay, so what makes a 10? Well, 1 times 10 and 2 times 5 makes it 10, right? That's it. Third step. We want to decide, now this is not different from the other type, the easy ones. Add or subtract to the middle term, we have to decide that. Okay? If I have a positive here, then what do? I have to add to the middle term. Okay? So here I want to add to the middle term. So I pick my pair that adds to the middle term. These do not add to the middle term. These do. 2 plus 5 is 7. 1 plus 10 is 11. All right, so these two add to an 11. So these are the ones I'm going to choose. Your fourth step is to rewrite the middle term using your pair that you've chosen. So what I'm going to do is I'm going to rewrite this. I'm going to split this middle term into 2 terms. I can rewrite an 11 as 1 plus 10, can't I? Or I could write it as 10 plus 1. It doesn't matter. I can say that 1c plus 10c is 11c. So what I'm doing is I'm taking this 3-termed polynomial here and I'm turning it into a 4-termed polynomial. And what did we say about 4-termed polynomials that have nothing in common? We can group. Okay? So now I'm going to go back to my grouping stuff. I've turned it into that on purpose. Okay, what's in common there? Well, I have a c. That's it. I'm going to divide through by c, each one. This becomes a 2c. This becomes a positive 1. Now I'm going to group these back to, I have a 5 that's in common with those. I'm going to see what's left. Well, this is a 2. Got the c still. This is a 1. See how I forced those to be the same again? So now I went from 3 terms to 4 terms down to 2 terms. What do these 2 terms have in common? So my last step is factor by grouping. And there, I'm not going to write down what to do because we know what to do there. We have the 2c plus 1 in common, and we have the c plus 5 left over, the outside pieces. So what would we do to check? Well, we would redistribute, refoil. We've got our 2c squared. We've got our 10c. We've got 1c. And we've got a 5. These two can be recombined for 2c squared plus 11c plus 5. And we are good to go. Okay? So this is your directions, and it works for every one of these, no matter how hard they are. Some of you might have learned trial and error method, and I think that's just really an ineffective way of doing these. So, all right, let's try this one. Same stuff. We've got, okay, we have 5c squared plus 24c minus 5. Okay, so again, 3 terms in the x squared x no x pattern. This time we have a lead coefficient of a 5 that we can't factor out because this term right here doesn't have a 5 in it. So we're going to use the AC method. All right, my first step is to multiply a times c. 5 times 5. Disregard the signs. I'm just multiplying this times this. Gives me 25. My second step was to make factors of 25. Okay, I've only got 2. Now I have to decide if I'm adding or subtracting to my middle term. What does this tell me? I'm always subtracting to my middle term. Which pair subtracts to a 24? That one. So now I want to rewrite this using these two. Well, it's a positive 24, so that means my 25 has to be positive and my 1 has to be negative in order for that to work. Right? Is that correct? Doesn't this recombine for a positive 24? Negative 1 and a positive 25. So now again, I've turned my 3 terms into 4 terms, and I'm going to group my front 2 and my back 2. So between these two numbers, a 5 and a 25, I know a 5 goes in there. And between a c squared and a c to the first, I can take out a c. So I'm going to see what's left. I've got my c there, right? 5 divided by 5 is gone, so all I have left is a c. And I've got a positive 25 divided by 5 is a positive 5. And my c's are gone. Now between these two, I don't have anything in common. But I don't want them to be negative, so I'm going to take out a negative 1. There's always either a 1 or a negative 1 in common with these things. So if these were both positive, I would just take out a positive 1. All right, but if I want to, I can also take out a negative 1, and I can change all my signs. So here a negative c divided by negative 1 is a positive c. And a negative 5 divided by negative 1 is a positive 5. Now again, I'm forcing these to match. Now I've turned my 3 terms to 4 terms to 2 terms, and these 2 terms have a c plus 5 in common, and what's left is the outside pieces, the 5c minus 1. Redistributing, here's my 5c squared. I've got a negative 1 and a positive 25 for a positive 24, and my negative 5. Bing, bada, boom. Done. All right. So I'm not going to do all of these for you. They're all done the same. I'm going to do this last one though, and then I'll be done. But here I could do factors of whatever 12 times 32 is. What is 12 times 32? Who knows? Enormously big number. I could do factors of 384. Boy, that's a lot of work, right? Or I could take out a GCF right off the bat. Now I can't take out the whole 12 to make that into an easy one, but I can take out a 4. Because there is a 4 within each one of these. So I can cut down the numbers. So here I have a 3x squared. Here I have a excuse me, 2x. and here I have a negative 8. Now what I can do is I can make factors of 24, which is a lot easier than making factors of 384. Right? I can just work within this. So you're just going to want to keep going with this thing here. Okay? So whenever you can, pull out a common factor to reduce your numbers down so that it's easier to work with. Please try that. I mean, go for it. All right? Now if you don't, then you might have to, one of these pieces in here will have still a common 4 that you still have to take out. So it's easier just to take out the 4 in the beginning. Okay? All right, so that's 6.3. That was a nice, quick, easy one. The next section, we'll continue on our factoring techniques. They won't be, what do we have? 6.4, no. We're skipping 6.4. That's what I was going to say. We're going to skip 6.4 and we're going to move on to 6.5, which is special factoring techniques. I'm going to skip sections where I can, where it makes sense to skip sections. So we're not going to cover 6.4. So we'll do 1, 2, 3, and then we'll skip 4 and skip 6. So we're going to move on to 7, and then if there's an 8 in here, let me see. Yeah, we're not going to do 8 either. So, all right, so I'll see you back here for 6.5.